So my name is Chad Curry. I'm Managing Director for the Center for Realtor Technology at NAR. And this talk is really about stuff that we're doing, and we're asking for help. We're very interested in finding out more about projects in the Erlang community that are focused on IoT. The way I see it, it seems to be the perfect language. Come on in. You don't have to. It's all right. Seems to be the perfect language for this type of work. Here's how you get a hold of us. We have a new Twitter handle, CRT Labs. I'll talk a little bit about that and what that means. CR Tweet is our standard handle. And we have a blog where we post a lot about technology that's happening all over the world, not just focused on real estate, but stuff that's happening all over the place. We also have another blog where we're putting a lot about our work and what we're finding in the IoT space, not only in the home, but community and citywide. We have a GitHub, and it is github.com/National Association of Realtors. We made it really simple. Very simple to type. So if you misspell it, you know. But we have all of the code I'll talk about today is going to be posted up here. Chris Cote, who's our lead lab engineer, is right in the back right there. He's waving. And Chris maintains this for us and keeps the code posted. Come on in. So why is the National Association of Realtors here, right? And some people, when they think about real estate agents, they think about that, right? That's not us. We're not those. We actually adhere to a very strict code of ethics. We have 1.1 million members. They adhere to a strict code of ethics. And what's really driving our work in the lab and this whole IoT space is the preamble right here to the code of ethics. It starts with the line, "Under all is the land." All right, that sounds like a base for some sort of stewardship manifesto, right? And we say in here, this yellow line, they require the creation of adequate housing that be our members, the building of functioning cities, the development of productive industries and farms, and the preservation of a healthful environment. Such interests impose obligations beyond those of ordinary commerce. It's pretty lofty, right? We've been around for 108 years. This has changed very little. It's actually, the preamble was added about 60 years ago, and it's changed very little since then. So as I said, there are 2 million real estate agents. 1.1 million of them are members of our association, and they're all over the place. We have about 5 million transactions a year are done by our members, right? They're in more homes than anybody else. They're organized because we have a national association, and we also have 1,400 state and local associations. So when we talk about the lab, I'll talk a little bit more about what that means for us. We focus on residential and commercial. So yesterday, Chris and I were over at the Center for the Built Environment, which is at UC Berkeley. They're looking at how to do effective heating and cooling in buildings to save energy. And what they're coming to is it's actually a personalized thing. It's about behavior. And so that was a really interesting meet for us. And the reason we went to them is because we want to help introduce them to other groups out there. And we're global. You might, if you live in Canada and there's Korea up in Canada, there are people up there calling themselves realtors. It's because they're affiliated with us through our global program. This is our building in Chicago. This is a 1961 Gold LEED retrofit building, and this is our Washington, D.C. office. It was the first LEED certified building in D.C. in the year 2005. We work right about here. That's where we're at, a little bit back. So what is the Center for Realtor Technology? We are a multidisciplinary research and development group at NAR, and we look at what emerging technologies are coming on the market and what they mean for our members. And we try to inform the association as to the value or the pitfalls in that space. So as of last year, about a year ago, I worked with my CTO to rework our budget to form a laboratory because I saw renewable energy and IoT coming onto the market as things that are starting to gain some serious traction. And so we set up a laboratory. This is actually our workbench here. We have a soldering hood here and an area to do soldering and also work with other types of hardware. We have some breadboards there that we've worked with. And then right here, there's a little device that we got from Bosch that is, it's called an XDK. It's a development kit. They gave it to us before it went on market so we could actually see some of the sensing technology they have. They actually make a lot of the MEMS that are on the market. They're one of the bigger manufacturers. So it's a part of a partnership that we get to test stuff like this for them. So it's very exciting. We have a 3D printer. Now, we are using it because as we build hardware, we actually are very interested environmental sensing, and I'll tell you why in a bit. But as we build hardware, we also need to think about case design and putting that into a case. So we got a 3D printer. We've also printed a house with this as well to show people what that might look like. And this is an area we have meetings, and I want to tell anybody that's here that's interested in working with us, if you ever come to Chicago, we have open space. We actually like to have people stop by. Well, I like to have people stop by. I'm not sure about Chris and Dave and Joe, but I like it. It makes me feel good. But we have space where you can work and actually work alongside us. This is Dave right here, and Chris sits here, I sit here, and Joe sits here. And we have a number of devices up here that we've purchased, but we're also getting a number of devices sent to us by IoT manufacturers in the commercial and residential space. And so we all sit here, and this is where we do our desk-type work, programming and what have you. Now, if you can't make it to Chicago but are interested in meeting with us and talking to us, we have one of these as well. So you could actually log into our double robot and take a tour of our lab, and we would work with you on that. So if you have interest in that, come talk to me after. I can set one up for you. What's cool about this is we think about this for real estate being a way to do tours of a home, but also when I go and speak like here, and this is me teasing you because I'm not doing it, I could fire up the robot and we could actually tour the lab. Nobody's in there right now, so it's dark because everybody's out. But I could fire up the robot and do a tour of the lab and have a number of people see what we're up to in a pretty quick way. I'm on the board for the Internet of Things Council in Chicago. It's about 18 different groups represented. We're the only trade association to be a part of that. It's Accenture, AT&T, Cisco, the City of Chicago, University of Illinois. And what we're doing there is driving the adoption of IoT, but in a safe fashion. Like security and privacy are big concerns, and I'll talk about some partnerships we have in that. But we think that's we're bringing IoT to the Midwest and documenting all the companies that are working in IoT in the Midwest. So these are some of the partners we have. The U.S. Green Buildings Council, I presented to them last week, and they said, anything you do, we're a partner in whatever you do, because the type of thing we're talking about doing is in line with the type of LEED certification that they're doing. We're working on a challenge with the Department of Energy to take some software and build a hub that does energy monitoring, but also does IoT, smart home device control. So you have one place to go to work with devices and understand energy usage. And this group right here, did anybody hear about that Jeep that was hacked last year? Yeah. That was a group called I Am the Cavalry, right? And those are information security researchers who look for bugs in code and work with companies to fix those. We work with a group called Build It Securely. So when we meet with companies, we try to encourage them to have their code independently audited by Build It Securely to look for any glaring bugs or outstanding bugs. And that group can then fix it, or they can pay a small bounty to Build It Securely to have it fixed. It's a way to have it independently verified at a very low cost. We also have a lot of universities we're working with. This is the University of Michigan. They're manufacturing a moat the size of a grain of sand. It's called Smart Dust. And it has a sensor in it, but it also is energy harvesting. So it powers itself and it can mesh. And I see implications in drywall for room sensing here. We could tell what the temperature and humidity are all throughout this space by having these in our walls. Not tracking people. I have no interest in knowing who anybody in this room is. If I knew there were 30 people in this room, I wouldn't care who you were, just that there were 30 people, because it would help me make choices about how this room is heated and cooled. Right? Urban Center for Computation and Data, I'm going to talk about a project we're working on with them in a little bit. But these companies right here are all very interested in working with us because they see our membership, those 1.1 million members, as a path to a community. Right? We've talked to them about our members helping them get these devices into homes for testing purposes. Some of these companies have stuff that is available in Europe but not available here, and they want to test it here before they bring it to market. All right, so why Erlang? Why am I here? Right? This language, now I'm a front-end web developer, right? But I've had 2 years of experience at Erlang conferences, Erlang Factory, and we hosted an Erlang workshop last fall in Chicago. But I got to tell you, what's really intriguing about this language to me is it seems custom built for what the Internet of Things is: messaging and queuing, message queues, right? And the fault tolerance and concurrency, all those things, right? There's so much interaction happening with these devices as they come online. This seems to me to be the perfect language. And also Elixir, I found a project that was in Elixir that was focused on IoT. I think Earlything is another one that's focused on IoT. There's two companies that I know of right now that are using Erlang for IoT. One is called Helium, and they do edge network processing. They put sensors up in hospitals, and they need a very dedicated system for that. So they're using Erlang for some of their messaging in that. And VoltDB, which is doing a database for smart metering and smart energy. Anybody familiar with VoltDB? Cool. I'd like to talk to you about that. And then also, anybody familiar with Helium in this room? Great. Excellent. Back there too. Good. Excellent. Yeah. So those are two examples. So as I want to find more, because this to me, like I said, I feel like this is the language that is built for the Internet of Things. I mean, if you think about numbers of lines of code too, right? I was talking to Perry, who's in the DDoS over there, and he was talking about the numbers of lines of code they had. They went from 40,000 to 4,000. Now imagine that for security, right? Being able to debug much faster because you have less code to review. And as these things get online, they're supposed to be between 26 billion to 250 billion by 2020. So you want to be able to determine where the problem is pretty quickly. All right, so what is the value of a home? And this will get me to where I'm going. It's much more than money. It's actually about quality of life, right? And it's about the experience of having that home. That's where your value comes in. I want to talk about the concept of homeostasis and what that means for the value of home. So this is one of the definitions of homeostasis. It's the tendency of an organism or a cell to regulate its internal conditions, usually by a system of feedback controls, so as to stabilize health and functioning regardless of the outside changing conditions. It's also the ability of a body or a cell to seek and maintain a condition of equilibrium or stability within its internal environment when dealing with external changes. These are all things we see in a home, right? And I'll talk about it in a second. So as a normal cell, it has a nucleus. It can regulate functionality, its functions, and it's totally independent. As these cells come together, they start to build parts, and they can work together to build tissue, and all the organs and everything else that makes us up, skin. And those parts come together, as I said, to make a whole. So what I want you to think about then is take that cell, right, and think of that cell as the home. What's missing in the home now is a way for us to regulate the function, to get feedback, to know how it's working. So what if, as a closing gift, a member of our association were to give you a hub that did energy monitoring and environmental quality monitoring. It had sensors you could put up around the home. So you could then understand what the air quality is in here. Who has a Fitbit? I'm sure almost everybody has a Fitbit or some type of device, right? Did you care about 10,000 steps before you got one of those things? Right? Yeah. You don't know what you're breathing right now. I don't want to scare anybody. You don't know what you're breathing right now, right? You don't, simply. So what if you could learn what you're breathing, what the CO2 levels are, what the particulate matter levels are, the humidity, the temperature? Would there be value in that for you? Here's the value, right? Humidity levels, if they're too high, you're going to get mold or bacteria growth, which leads to illness. If the CO2 levels are too high, anybody been in a meeting before where you start falling asleep around 2:30? It's because the airflow in the building isn't so good, right? The CO2 levels are elevated. That's why you're sleepy. Respiratory issues, particulate matter. So, I mean, all these things go into effect. So imagine the home as a cell, right? Then you start taking data on aggregate and start to look at it. You can start to understand what's happening in a neighborhood. Certain housing stock types maybe have better airflow, so you can help that homeowner make better decisions about the home based on their housing type and other data models you've created from this data. And then connected cities, so that these become the tissue, this becomes the body. Anybody heard of the Array of Things project in Chicago? Excellent. That gives me something fun to talk about. That's great. So as I said, between 26 to 250 billion of these devices will be connected by the year 2020. And one of the reasons for that is that hardware has gotten smaller, right? This is a 5 megabyte hard drive in 1956. Let's see, yeah, the Raspberry Pi tweeted that. I thought that was fun. But that was 5 megabytes, right? And we've gone smaller, faster, cheaper with our data storage. We've gone from 79 kilobytes in 1971 on an 8-inch floppy disk down here to 2006, 4 gigabytes. So if I took these and laid them over here, we've got about 10,000 8-inch floppy disks worth of information in that same space, in that same footprint. And that happened over 35 years' time. Happened very quickly. Hardware, the Raspberry Pi Zero, $5 device, we actually put some open source home control software on it, and we're able to control our entire lab through that one Raspberry Pi, that $5 Raspberry Pi. The chip, a $9 computer. Raspberry Pi 3 is $35, and now it has Bluetooth connectivity. You've got the particle, Photon, $19, Bluetooth enabled as well. So what does the home of the future look like, right? When you look at this, the stuff's getting smaller. What does our home of the future look like? Well, Buckminster Fuller is somebody I really admire. He had some great things to say about space and about how we're living, but that's not the home of the future, right? This guy talked about the home of the future, the little pink house. We have so many existing homes that go on the market. Over 90% of the homes sold are existing, so we've got to figure out how to get these devices in there. Now, the reason I'm telling you all this is as these newer devices come on market, there are a lot of opportunities for them to run on Erlang. And they'll be extremely low cost, these devices, too, that are coming up. This is just a little background. So the reason I'm interested in this data is we're a member of the Better Buildings Initiative, which is part of the Department of Energy's program. This is a standards body for real estate. But we're a member of this to include information from the utilities in a listing. So homeowners can actually disclose what their energy usage is, because a lot of new buyers are very interested in that. We signed with an eye to the future because we think the devices that we're putting in the homes, the energy monitoring, can be a part of that same initiative. So what if you could auto-pop the data? If that homeowner decided to auto-pop that data, they check a box, they can send that data right to the listing. And you can see in real time what their energy usage is. Now, I won't say real time because you could tell patterns when people aren't home and stuff, but give you an aggregate sense of what the actual time in the home is. And this is where I'm coming. Currently, the data that we have in real estate is static, right? It's the same as the books they used to print 20 years ago. But what if we could actually make it dynamic? And that's what IoT is going to do. Quickly, I'll go back to this one. Hold on one second here. I'm caught in a kerfuffle. Let me come back. All right, so we worked on a platform in Python, and it's actually on our GitHub. It's called LabLog there, Chris, right? That's what we're calling it? LabLog. But we're calling it Rosetta Home as a holistic umbrella because we want it to talk to as many devices as possible. Now, for messaging, we're using RabbitMQ, which is, Erlang. But we'd like to think about what options there are in Erlang itself, actually. Chris did a great job putting this all together, but we're also curious to hear other people's thoughts on that. Each one of us have these in our home. These environmental sensors are called NetAtmos, and they tell us about the carbon dioxide level, the temperature, the humidity, the noise, and the pressure. This is a $99 device that connects to a smart meter and will tell you in real time what your energy usage is and give you feedback on that. This is a $180 device that you can connect to your electric panel if you're brave, and it will tell you also what your energy usage is. So as we take those, we have these listings here. And what if we could take the listings and add that data to this listing details? What if we could actually show what's happening with the home CO2 levels on an aggregate basis? What if we could show the indoor-outdoor temperature and the power usage at the same time, right? And talk to the homeowner about how to improve upon these metrics. We recently were watching this, and it was interesting because we saw in Chris's house, power was going down as the temperature went up. It was very clear. And then you also have power and cost and indoor and outdoor humidity. So what if conversations could happen about the quality of life that person's leading, and you could help them improve upon those metrics? You're going to improve their satisfaction. And when that home comes back on the market, problems that we tend to run into with those, humidity and CO2 levels and airflow, those tend to be mitigated in a much faster basis. This right here is a Sankey diagram we put together. Green, just to tell you really quickly, green indicates environment, yellow is energy. And what we're showing is, the messaging working in real time. Now, these are these are not our addresses, but these are our homes. And when they light up, that's actually data coming from our homes. So what we're able to show here is as this data is coming in, it's hitting this device right here, the NetAtmo, and these are the fields. So now CO2 is hitting right now, right? And then we can have triggers set up. So we can actually have something set up to turn our thermostat on to get the air flowing in the home. Because what if you live in a very highly enveloped area, a sealed home, one of the newer condos that the windows don't open? You need to have that airflow going. So you could start doing things automatically and have that homeostasis effect happening in the home, right? Chris, do you want to add anything about this?
This is really where the name Rosetta Home comes from. What the idea here is you have your sources on the left, your structure, your cells. Next to that is the different interfaces, right? We normalize all this data to RevMQ, to these to our data types or values, and then to the different message queues there. So this interface is actually a real-time client listening on the everything message queue. Let's say you have a constrained device that's dealing with a little bit of memory and a little bit of bandwidth. You can selectively bind to any of the queues to pull data. So if you just want to react to energy data or anything like that, the idea is that it gives you a normalized interface to all these different devices or interfaces. This is real-time representation of
Yeah. Yeah, so the bigger point, and I'm just going to repeat a little bit of what Chris said for the audio, but the bigger point is this is real-time messaging happening, so we can have it automated. It's where the name Rosetta Home came from. Just a quick summary. But the great thing about this, too, is the DOE is very interested in automated demand response and saving energy through automated demand response. And something like this could then be applied to that as well, to help with that type of functionality. So as Buckminster Fuller said, automation replaces the automaton in this case, right? Now, what I mean by that is our members are entering data into these listings, right? So our industry is, and I'm not the only one who will say this, we're a little bit behind in distributed systems, right? And scalable systems. And I'm talking about we have 770 different MLSs, multiple listing services. None of them share data, right? They don't share data. For me to get access to all that data, I would have to have a license with each one, right? And that license may exclude me from doing certain things, right? So if I'm a member and I join, if I have 3 MLSs in my area, I'm in a tri-state area, and I'm in 3 MLSs, and I want to put one listing up, I have to enter into each MLS, all 3 of those MLSs, right? And we talked about APIs at an event, and it was like a revelation one time. So that was kind of exciting. But so it's something that we're trying to help our members actually focus on the work they need to do, and make these listings more informative for the person who's interested in buying the property. I would love, after the talks this morning, I would love to bring some of the executives from the different MLSs in, just to show them some of the stuff we've talked about theoretically, how it actually works here. It's pretty great. So, this is a real estate news source. A good practice is always to know as much as you can about a property before you buy or sell, and that's exactly what we're trying to do, is to give power to that homeowner, but also improve their quality of life. That's a big thing for us. So I'll talk a little bit about the connected home and home performance. One of the big things, anybody here have a Nest thermostat or equivalent? I don't want to be brand specific here. Yeah, one of the great things about it is they're saving energy. They're actually saving energy for the utilities. And utilities are very hip on them. They like them because they help them do things like avoid brownouts or having to roll over to more expensive peak level sources. So Austin is a great example of this, where Nest went to them and said, hey, we know we have these many Nest thermostat owners in your area, and if you have them enroll in a program, we can actually save you from rolling over to other energy on the hottest day of the year. And sure enough, they were able to do it. 4:30 came around, they were able to kick the thermostats down by 1 or 2 degrees, or up by 1 or 2 degrees, and there were no issues. Ambient light quality is a big thing, and we think that's also being improved in this space. And one of the problems here is these devices, for the most part, talk cloud to cloud, right? So we have a lock in our lab, and it's by Schlegg. And Dave can stand 10 feet away from it and hit unlock on his app, and it'll take 3 or 4 seconds for it to unlock, which by the time he could have gotten the keys out of his pocket and unlocked the door, right? So this convenience is coming at a bit of a cost, right? So how do we speed that up? And that's where I think the messaging could be really, really helped out. But also, not having it be cloud to cloud is another thing I think could be really helpful for this. I think this right here is going to be huge, and I think this is where a lot of the data is going to come from. Now, I should say, too, about the data that we showed you, the real-time data. We can slice that however we want, as you know. But I think that this type of data right here will be huge for the homeowners in the very near term. And I think comfort and health are going to be the two big things that drive adoption of these devices. So as we build environmental quality sensors, I'd love to, there's a talk at, Kenji's talking at 5 o'clock today about sensor nodes on Arduino. I would highly encourage you to attend that talk as well. I'm very interested in what he has to say about that. But all this stuff impacts the health. Now, this right here, I went to visit the University of Michigan, and this was a curtain in my hotel room. I'm lucky I looked up because that's not good at all, right? So what if the hotel actually had these sensors in there? You'd be able to know that you had this humidity level that was causing this mold, right? I mean, these are just example after example in people's lives with this stuff. I'm going to talk about connected cities, and then I want to do some questions too, because I'd like to talk more about what we're doing and what it means, but also get a sense of what your thoughts are about how Erlang could be a part of what we're doing. But there's a project in Chicago called the Array of Things. Now, we're talking about the home and home level data, but we also, if we could know the city level data, it would be extremely helpful. This is a project by the University of Chicago, the City of Chicago, Argonne National Labs, and a group called the Urban Center for Computation and Data. And in this project, they're building an extensible system. It's called Waggle. Now, these pieces, there's about 60 different sensors they have in a node. And the great thing about that being extensible is if they deploy these in Tucson, they're not going to care about precipitation as much or humidity levels as they will about particulate matter, right? So they could add more particulate matter sensors. In Portland, they want to know about humidity levels, so they'll add more humidity sensors in there. And they have there's 8 different air quality sensors happening right there as well. They're deploying these. They got a grant from the National Science Foundation to deploy 500 of these around the city of Chicago, and they're going to start in April of this year. Now, they've asked us to do some testing of the hardware and the software, some debugging of the software. Chris, are they using Python for this?
The backend is Python.
They have a thing called Beehive, right? Yeah? They have a project called Beehive. And it's interesting, we keep hitting these Python projects, right? So I'm very curious. I'd like to see some analogs. So I'd love for you all to look at what we're doing and talk to us about what you see there and what you think, what changes or what things you would add from the Erlang community. But Beehive is something we're going to help debug. And they want to put 3 of these on our building. And this is the first iteration right here, second generation, and third generation. Now, types of data they're capturing here are about air quality, temperature, humidity, noise levels, particulate matter, and they actually have an HD camera. Now, here's what's happening with the HD camera. It is not recording who I am. It's more like a clicker, right? And we've actually talked to the staff there because we don't want to be involved in anything that's going to violate someone's privacy. That's not where we're at. We take that pretty seriously. All 4 of us, actually. We're very, very keen on that. But essentially, it's working as a clicker. It's also working to help find heat islands in the city. So you can start seeing these microclimates, right? You can start seeing where reflections from that skyscraper in Chicago are causing it to warm up in the city and cause other issues in the city itself. It also has, they want to count foot traffic, bicycle traffic, and car traffic through those spaces as well. So they can get a sense of how it's flowing through the community. This is what they're going to look like. This data, when it's captured, will be open. So a great project could be to build something off of this data once it's out there. It's going to be part of the Chicago's open data portal, and part of their agreement with with the other cities in the NSF is that all the data that comes off of these will be open. And this project's going to go global next year. It'll be Mexico City, Antwerp, I think, is another city partnering with them. And New York City is going to have these up, and Austin, Texas, as well as Portland and a few others. But we're thinking this could be really interesting. We're talking about larger cities there, right? But what if we could bring this to smaller communities like my hometown of 20,000 people in Iowa, where you could help people see what they need for CO2 mitigation on a larger scale. Maybe they need to plant more trees. Maybe there's a high concentration of carbon monoxide by an elementary school. In fact, a friend of mine, their son was going to a school that had a CO2 leak from the boiler, and CO leak, and the kids got sick, right? Because there was no sensor in the building or anywhere near the building. So what if we could help mitigate that by having these types of sensors up there? Now, what this is going to do for us, our members, is it's going to give them information about that community, which will help them, in turn, work in that community, because our members like to see themselves as community experts, being local experts. And if they can help get systems in like this that help improve a community, that goes a long way to raise them up, right? To have them. And I think that's the new way our membership is heading, in a way that helps them become an advocate for that community. So these are the partner cities, as I mentioned. And I put a little, this is actually something, so Chris and I and our teammates, we were in a hackathon. It was the IBM Coding Virtual Hackathon. And we did this visualization. We have a number of visualizations, but what I'm demonstrating here is it can be really cool to take the data from something like the array of things, and and this is 15-minute increments here, Chris. Yeah, this is actually people moving around a city. But what if we could actually show? And I don't know who the people are. I just know that there's movement in the city. But what if we could actually show how these devices, or how the movement of those folks is impacting temperature and the commercial spaces? So that's going to be really interesting. I think next year, or maybe a year after, when we have some data from these devices, we'll be able to show things like this. So we're going to put. So they want us to put one right here, and one right here on our building, so they can get a sense of air quality all up and down the front of our building. Our building's on Michigan Avenue, right next to the Wrigley Building, and what that'll allow them to do is start painting a really interesting picture about things like where they could place vertical axis wind turbines to harvest some energy for the city, right? Where they could get some solar reflection for some ancillary solar panels, or what they could do to improve air quality in a specific part of the city. So this is coming in the next year, and what I want to say too about what we're doing is that we are very open in what we do. So anything we build is going to be available to you. So outside of this, if you want to see some of the stuff that we're doing, always feel free to reach out to us. That's a big thing for us, is to keep it open and to keep it available to folks. Really what we're trying to do is build a system of systems, and we want your help with that, right? I think this language is perfect for it, and I think that we could do some really interesting things with that. And so I'm going to stop there because I want to ask some questions. I want some questions. I want to see what questions you might have. Any questions about programs?
All right, I've got a question.
Yeah.
So how long have you been looking into Erlang, and have you tried developing any software with it in-house?
We haven't yet. Chris, go ahead.
Yeah, I've been doing Erlang for about 2 years, since like AUTOMATON 2014. I'm just so comfortable with Python at this point. I just develop that much faster. But I am thinking of actually looking at Elixir and Phoenix for the API aspect of our Rosetta HOMEOSTASIS Lab Log. So I've done these
Chris, why did you choose RabbitMQ for the messaging?
I mean, I've gotten into arguments over RabbitMQ several times. There's something like 0MQ. I thought this was a really, the idea was to create this kind of CAN bus, similar to a car, CAN bus for the home, right, where you plug in any device and it's normalized interface, and the message queues and just kind of the design of RabbitMQ really fit that, and it's extremely scalable. Also looking at some of the data, so we mentioned the home, the city, the national level. RabbitMQ has some really interesting ideas around federation, which I thought was very interesting. And I think Erlang is at the core of that kind of federated idea of multiple nodes and how they communicate. So, and well, you can use the Erlang, or you can build use the system built on top of Erlang to do that. But the federation of data is a very good for that in future ways.
And you had also talked a bit about privacy, and it looked like the prototypes you had were centralized systems.
Yeah.
And so where does that privacy happen? Like, how are you thinking about anonymizing the data and
Yeah.
making sure that nobody can reverse that anonymization?
So, okay, so what I'll talk about is privacy, right? So this is an example of what could happen. We don't think everybody is going to choose to have that data initially to have it listed somewhere. They're just not going to, because they may not trust the system, which is fine. We think as people see the value of it, that's where it then becomes a thing that they would have it incorporated into what they're listing, right? So the system that we're talking about would be one where they could check a box to share only certain types of data. One of the companies we're talking to is Canary. They make a video camera that also does environmental sensing, right? It does temperature, humidity, and particulate matter. And I don't want anything to do with video or audio from that device, right? So we have to segment those pieces out. But as far as normalizing and all that, Chris, if you want to talk about some of that or anonymizing it.
Again, the federation of the data, it really comes down to that again, where locally you have access to all the data, right? And your home and that edge device, you have access to every piece of data. As it gets federated up, or reported back to an LS, or wherever it's going, you have different. The idea is that it aggregates at different levels as well, right? So in our examples, you saw CO2 at a daily, and energy use at a daily application. That's way too granular to actually publicly put out on notes, right? You can know if somebody's home. You can you can really dig into the data there. So you'd be looking at again the federation of the data, the aggregation levels. As far as specifics around anonymizing it, on our backend system, it's all based on generated viewing that doesn't really have any ties to any. So there's an interesting concern where how valid is this data if you totally anonymize it and remove any geographical information about it? You really need the geographical information to make it relevant to any given topic, right? To know CO2 levels are this, but you don't know where, does it really give you any valuable insight? So there's some balancing I think with that as well. So again, it's at the level of the aggregation that we want to do that.
And there's also, it comes down to education. So there are different ways of displaying it for educational purposes. So like Chris said, you aggregate in a way that doesn't give you any identifying information as far as when someone's home. We're not interested in people being broken into. It's not what we do. So we actually, you could use even more granular to talk to that homeowner. Kind of do a fitness check-in, almost like a doctor for the home. I don't want to say that as what we do, but that's a way for you to have that conversation. So, yeah.
Any other questions?
Yeah, Brian.
So a lot of this is centralized right now, but if I wanted to just start my own and see what emissions are inside of my house, is that possible to do? Or are the devices that have been shown, do they just report somewhere else and they're
Well, so we're partnering with NetAtmo. We actually reached out to them, and they've partnered with us to have those devices report. But, Chris, I think you have stuff that we haven't.
We've got multiple. So I
Yeah.
run, like I said, this is open source. We have our centralized version running in our cloud, our data center, right? Somebody else's computer. I also have a version running locally at home that talks to all my devices locally. Again, the idea of normalizing it is some we can talk to, some provide a native, a local API, others are only cloud. We have our own platform built on Photon that you can tell it what endpoint to talk to, and it'll report to that one. And so that's a push type system, which I really like versus polling devices.
And I didn't repeat Brian's question.
It really depends on the interface, whether we're polling or pushing, or if it's local or cloud or all that stuff. So.
Yeah, and Brian's question was, can you use this locally as with whatever devices you have? Thank you. Yes, sir.
This seems a little bit related to something that is happening also right now,
Great.
which I'm going to talk about tomorrow, which is standardization and sort of an open source push for
Yeah.
connected cars.
Yeah.
Being able to come into a car, or perhaps talking about, for example, decentralized communication, also, and the security aspects.
Mm-hmm.
Like we're trying to solve how, for example, if you rent your car to somebody, you can send them virtual keys so that they have access to the system. They can access stuff inside
Yeah.
the car. Be able to do that securely, revocable keys, whatever, and right, or yeah, various things. I mean, it's a very open field, but I'm thinking that it would be probably extremely cool for users if these technologies that work with the car also are compatible with what you can do with the home electronics, whatever.
So the nut of what you talked about is standardization, right? That's the big problem with this whole thing. That's why this is called Rosetta Home, right? We want to have one thing that works. It's Lord of the Rings all over, right? One ring to rule them all. That's what we want. And we don't want it. We don't necessarily have to be the people that do that. We're just saying it's there. We need to do that, right? So things like Thread happening, IoTivity from Linux Foundation, that needs to happen, right? And so it'd be interesting to have a cross-industry one. That's intriguing to me. Yeah, yeah, we should definitely talk. Okay, great.
Did you talk about the Haystack project?
I'm not. That's one I don't know.
So this is a whole bunch of folks that are trying to haystack.org or something like that. They're trying to figure out how to they're trying to solve the layer 6 presentation problem for how do you describe units of things coming out of devices. So this is like, HVAC devices, all these other types of things, put out units, but they don't tell you what they exactly.
Is it here?
Probably.
Okay.
Smart data, smart device. Right, so these guys are trying to, when I looked at them last, maybe 2 years ago, they were trying to solve how do you deal with a layer 6 problem. So devices put out information in units, but they don't, in numbers, but they don't tell you what the units are, right? Because the physical world is missing from the output of these things, right? Do they tell you the temperature in Celsius, Fahrenheit, all that other type of stuff? So there's a huge problem in the sensor industry is that people got no way of figuring out what the device is actually physically telling you.
Yeah.
Right. There's a larger, that's extremely important as well, there's a larger push for describing the security protocol that you're using, right? So you have all these different devices, certain...
So that's a completely separate problem.
I think so.
Any of this stuff without the security problem, but you can't even, you can't even figure out what the guy is telling you.
Right, but you can't parse the data, you can't. So I think it is separate, but I think that same endpoint to describe the security protocol is also used to say, hey, this is, once you are able to parse it, this is what it's going to show.
So I think we're out of time here, but it's lunchtime, both up on this floor and downstairs, and if you have more to chat about, I'm sure lunch would be a good time for that.
Thank you. Thanks.
Thanks again, Chad, for giving this wonderful talk.
Thanks.